Well, welcome back, everyone. Thanks for coming back. What I've asked you to do last time is to help us figure out whether those numbers, those consecutive integers, 1, 2, 3, 4, and 5, representing those 5 health states, were reflecting order, which we probably all agree they are, but also distance. And if so, it would make sense that we could report average health status, average health states for a group of people, if each person answered that question. So remember, what I asked you to do was to draw a line, anchor one end of the line by the worst possible health state, which was poor health, labeled by a 1. The other end of the line, anchor it by the best possible health state, excellent health, represented by the number 5. And I asked you to draw X's that would represent the location where you would put those other 3 health states: very good health, and fair health. So you might place an X for very good health at that location, another X for good health at another location, another X for fair health at a third location. Well, I asked students in the class to do this at one time, and then I took their pieces of paper, and I took a ruler, and I measured the distance between poor health, the end of the line on the right, and their first X. I then measured the distance between poor health and their second X, which represented good health. And finally, I measured the distance between poor health and very good health, which was represented by the third X's. I had about 30 or 40 students do this, so each student had a number, a distance, representing the location where they put fair health. And I measured the average of those numbers that they gave for those distances for their first X, and did the same thing for their second X, the location for good health, and their third X, the location of very good health. And what I got for the results were the following. These are median of their values, median locations, but the means, the averages, were almost the same. So they reported that very good health would be represented by an X whose location on a 5-point scale, say the line was 5 centimeters long or something like that, not at the centimeter point corresponding to 4 centimeters, but 4.4. In people's minds, very good health was close to the state of health represented by excellent health. The location for good health was represented on average by an X that was not in the middle of that line, halfway between poor and halfway between excellent health, not by a 3, which is in the middle between the numbers 1 and 5, but by a value of 3.3. And finally, they represented fair health as essentially being 1 unit higher, 1 centimeter higher on a 5 centimeter line scale than poor health. Meaning that if we were going to use individual answers to people's responses to these questions, if I gave this question, how would you rate your health? Excellent, very good, good, fair, and poor. And I wanted to report an average health state for that group of people. I'd have to use numbers that represent both order and distance. And my students at least suggested the numbers I should be using are not the consecutive numbers 1, 2, 3, 4, and 5, but numbers 1, 2, 3.3, 4.4, and 5, because the students in that class said that the gap between, say, fair and good health, represented by the distance between being a value 2 versus a value 3.3, was wider than the gap between, say, very good health and excellent health, represented by the distance of 4.4 to 5. So if you do want to report an average using the responses to this particular question, the better numbers to use, the numbers that reflect both order and distance, would be the numbers on the far right here. And interestingly, if you go and use the SF-36 and look at their manual for how to score their questions, for this particular question, how do you rate your health? Excellent, very good, good, fair, poor. They recommend using numbers when you calculate averages that are not the consecutive integers 1 to 5, but are very similar to the numbers that my students reported in this class, reflecting again that in people's mind, the gap between good and fair health is much wider than the gap between, say, very good and excellent health. So the numbers on the far right would be better numbers to use to report averages if you wanted to treat this particular measurement as if it was measuring health on a continuous scale. Well, the last thing I'd like to talk about is averages. And I want to leave you with a quote. I'm a baseball fan. Here in the States, one of our major sports is baseball. Well, we know from Marcello's lectures how to calculate averages. Marcello said that averages are measures of central tendency. The way you get an average is you take each person's value, you add them up to get the total number, total values for everybody in your data set, and you divide by the number of people, the number of values you had. So in the previous example, if I gave that one question, how is your health? Excellent, very good, good, fair, poor, each person would give me an answer. And to report the average, I just add up those 100 answers and divide by 100. But here's a quote I want you to end with. I want to end with today. I want you to keep in mind, because we're going to be talking about averages a lot in this course. In the next sequence, we're going to be talking about incidence and incidence rates, and you'll see averages are going to come up there. Later on, we're going to be talking about confounding and adjusting for confounding via stratification, and averaging is going to come up there again. In the following sequence, we're going to be talking about effect modification, and averaging is going to be coming up again there. Well, Bobby Bragan is not an epidemiologist. He was a baseball manager of a baseball team here in the United States. Baseball is one of those sports which is quantified in many dimensions by using statistics. Players have their batting averages reporting, the number of home runs they hit. Pitchers have the number of wins and number of losses. So there's a lot of statistics captured measured on baseball players. Performance measures. We're hoping that these statistics, these performance measures, have something to do with that player's ability to play baseball. Hopefully those numbers have something to do with the chances that a team will win a game. Well, Bobby Bragan came up with a very interesting quote. It says, say you are standing with 1 foot in an oven and 1 foot in a bucket, an ice bucket. So half of your body is burning up, and the other half of your body is freezing over. And Bragan said, according to the percentage people who report averages, you should be perfectly comfortable. Well, that's an example where an average would not be a very good description to describe a person's health state if half of his body is burning and half of his body is freezing. We might be able to calculate averages for health states, but the real question is you should be asking yourselves, does averaging make sense? And we're going to return to that question a few times in this course. So just keep that quote in mind. I'll return to it in the future in a couple of other lectures. But I'm going to end now and come back, and we're talking about probably the most commonly used outcome measures in epidemiology.